The third generation of Ames constructed assemblies is known as the C, which stands for a Colt series. They also have an M, which stands for a Maxim series. So they had a C200, C300, 400, and 500. Again, double check detector, RP, and RP detector assembly. They also had a family group of the A designation on the end. So there would be a C200 and a C200A. The C200 meaning the presently produced unit. The 200A was an interim unit that was produced in the beginning. This assembly began production under the Hunter name around 2000, and in 2002 Watts bought the Hunter valves and put them under their name designation as Ames and Watts, and sold under both names. Sold as the model 757, double check under the Watts name, 757A for the same as the C200 and C200As. The C300 being a double check detector assembly, C300A, same story. The valve again produced in 2000 to 2002 under the Hunter name, bought by Watts in 2002. The C400 being the reduced pressure principal assembly in sizes 2.5 through 10 inch. The C500 is the reduced pressure detector assembly, same sizes 2.5 through 10 inch. They also produced an M200 and M200A series, the M standing for Maxim. And the Maxim series was kind of similar to what they did with the SE designation, where remember in the 00SS designs, where they had an SE, which was one pipe size smaller parts inside than a standard SS. Well, the M series, designed for Maxim, was to have a maximum amount of flow through it, which would help it with its head losses. So the parts would be similar between the C series and the M series, but based on the size ranges would have different parts inside of it. So the C200 series, double check, M200 double check, C300, M300 double check detector, C400, M400 RP, C500, M500 reduced pressure detector assembly. A designation being the original introduction of the assembly, which had some changes with the type of linkage that was in the check assemblies. And these are what the different models they produced under this original Hunter design. So the Colt and Maxim series, again, stainless steel tubing, relief valve mounted underneath the check body, external relief valve sensing line. Notice the flange connections to the shutoff valves, where most assemblies in the flange sizes have flanges, flange gate valves, flange end body. The Colt and Maxim series does not have a flange end configuration on their check body. It's actually a groove coupling, so the shutoffs will always be a grooved by whatever type of connection you're going to, whether it be flanged or it could be a groove by groove. Also, by placing elbows in strategic locations, they were able to come up with some orientations that may help on installations. Check for areas to make sure approvals are all in your area. The big problem, remembering with when you put the elbows attached, was that a lot of times it changed where the relief valve sensing line was attached. Sometimes it was attached to the check, to the test cock. Sometimes it was attached to a separate port on the shutoff, depending what type you had. The internal parts looked like this. And here is our check mechanisms on the left and the relief valve assembly on the right. And the relief valve assembly unthreaded off of the bottom for the average repair. Relief valve sensing line came off. There was two types of check mechanisms, what was called a bi-link, meaning it had two link mechanisms, and a tri-link, like you can see here for the three type of mechanisms, which we'll show you when we take it apart. So let's go ahead and see what the Colt Maxim series looks like. Here's an N configuration, inlet on your right. Notice that the test cocks, test cock 1, test cock 2, and test cock 4 are all mounted on the shutoff valves. This particular version happens to be butterflies. So one of the problems becomes if the butterflies are put on first reversed, or if somebody changes the shutoff valves and they don't have the test cocks in the right location, you've only got one particular test cocks on this assembly, which again is the number 3 test cock here. So first thing, making sure of that the shutoff valves were installed properly. Again, part of the approval process does require that they're delivered with shutoffs installed properly, but again, out in the field, people change things, take it apart. Very important to know where the test cocks are on this particular model. Also important to know how to test it. So this being the RP version, here's test cock 1, 2, 3, and 4. Relief valve sensing line is an external relief valve sensing line, similar to what we've seen on the last 2 generations. The relief valve mounted underneath, as we've seen on the other ones, and looks similar to what we saw on the SS, but there are some differences in there. We'll take it when we get it apart. You'll notice that there is a sleeve, this mechanism right here that slides on the part here. Well, that's very important, which we'll take apart when we take it apart. Noticing where the relief valve sensing line is important, because the sensing line is attached to a lot of different locations. This is an end pattern, so it happens to be attached to the elbow. With the horizontal pattern, the elbow came off of the side of the test cock. So where the sensing line came had to do with where the shutoff valves were in that particular assembly. And again, it's a stainless steel tubing. This time it is not a fabricated body. It is a solid piece of tubing that is constricted in shape, but from end to end dimension is the same dimension time after time because it is a piece of tubing. So let's go ahead and take one apart. This third generation, as we saw in the picture, a little bit different than we saw with the fabricated stainless steel or the fabricated steel, obviously, in the third generation. And when a manufacturer makes a new generation, believe it or not, they do try to improve product over the years from the very early days of the fabricated steel. This happening to be a 3-inch RP. As you can see how much smaller they've got it than the original fabricated steel and even the stainless steel designs. Again, the relief valve sensing line is a key thing. Got to remember it's connected to either a shutoff valve, a fitting, something on the downside. But the most noticeable thing on the body, and here's one without shutoff valves, is there are no flanges on the inlet or outlet side. In other words, the body has a groove coupling. So how it's attached to a gate valve, butterfly valve, ball valve, whatever it's attached to, depending what size it is, the shutoff valve is attached by a groove coupling. We've already talked about how groove couplings work in the SS series, but very important to know that there is no flanges. So for a retrofit installation, this would be hard to replace without a conversion kit to put a flange on there. Now, before you take it apart, there's a very important thing I want you to try to read, if we can pick this up on the camera. And what it says right here, this happens to be a Colt 400 RP version, and what it says right here is, to service valve, remove test cock, slide cover. So that's telling me I have to remove the test cock, slide the cover to surface it. Then down here what it says in much larger letters, do not paint body. What they're referring to is this section over here. They don't want any paint applied to this section away from the sleeve over here. Again, remember this is going to be connected to your first check, your number 1 shutoff valve and your number 2 shutoff valve on the right side here. And they don't want any paint along here. Why? Well, I'll show you in just a minute. So this area is important that it not be painted. So first thing I want to do is wipe my hand around it. Make sure there's no pipe wrench, similar to the SS design. No pipe wrench marks, no baseball marks, nothing making it so it's not perfectly round. Next, I want to see if there is any paint or any kind of surface on the outside. Even if there was a pipe wrench mark that had a sharp angle, I got to make sure there's nothing sharp on here. So removing paint, I highly recommend something like a chemical, something to get the paint off of there, because you don't want to use scratching stuff, because if you leave any marks on here, you'll see why that's going to be a problem in just a minute. So this area has to be perfectly clean before I can disassemble the body. Let's go ahead and remove the relief valve for now, just to get it out of the way so I can show you the checks a little bit easier. Unlike the other relief valves where we had to, where you couldn't grab it, this one has a cast body, unlike the SS, which had that tubing body. So it's a square-shaped cover, making it easy to grab a wrench across here. It should only be hand tight, which again tells me that it should be an O-ring seal, and there is an O-ring seal that sits right inside here. We'll put the relief valve over on the side for a minute. Now, back to what they're telling me, do not paint body. So to service this valve, I have to remove the number 3 test cock, which is sitting here. Remember, 1 and 2 are on the shutoff valve, and number 4 is on the number 2 shutoff valve. But the number 3 test cock unscrews very easily out of this body. This has been a problem sometimes when people have been testing this assembly and they've got their fitting in here for the number 3. They go to put the wrench on there and they're looking up at the body or something like that, and all of a sudden the whole test cock starts moving and water comes shooting out of here. So this test cock comes off very easy, and you can tell the thread on it is not a standard pipe thread, but an oversized thread, and seals by an O-ring. So the number 3 test cock has to come out first. Now remember, this is sitting between shoe shutoffs at this point. Now what I have to do, and there's a small little boss here on there that allows a pin to go in place, and this allows me to get a little bit of grabbing ability so that I can slide this check assembly open. So as I move this slide over here, it exposes this piece here, which has my check assemblies inside. So that's why we can't paint this area, because as we slide it over there, there are 2 O-rings, one that sits right about here and one that sits right about there. So when it slides over, if there was paint over here, if there was any kind of wrench marks or any kind of scrape marks, you would slice those 2 O-rings. Now, for the normal repair, the O-rings in this slide do not have to be replaced. But you can tell that if I did have something here that sliced it and it went like this, or it had paint, now I'd be slicing those O-rings and have to replace them. We'll talk about those in just a second. Let's go back to the check body. As I said, it's a stainless steel body, but it is not fabricated. It is one piece, as you can see. So we don't have the issues of the end-to-end dimension with the welding. To remove the check assemblies, we remove the check guide. It comes out in one piece. First check assembly comes out first in one piece. Second check comes out next. The body, there's nothing to look inside of it. Same things we talked about with the small design check assemblies where the body has to seal on an O-ring, and that O-ring sits right in this slot right here. So it slides in place, and that O-ring seals right there inside the body. If for any reason we see any stretching of the body, this is a much stronger tubing than it was on the smaller 2-inch and under design, so it should not be as much an issue. But again, in fire applications, 500 horsepower pumps, they can put out a lot of pressure if you're not careful. Anyway, let's put the body to the side now and take a look at the check assemblies. Check assemblies on the Colt and Maxim series are basically going to be two different types. Whether it is a double check or an RP, you're going to see what's either called a bi-link design, which, like this check, has two cam arms. One cam arm, the long arching one, and the small connecting one here. So it's called a bi or two-link check mechanism. There is also a tri-link mechanism. You'll notice that there's three arms. One here with a knuckle there, second joint, and the third knuckle right here. So there's either tri-link or bi-link. And those are the two different types of check designs. The check rubber will either be silicone like you see here, or the black Buna end, depending which model it is. Remember, there's an A and a non-A model, and also depending on double check and RP. And it uses a torsion style spring. You can see the check action as it moves back and forth, that it's twisting that spring right here as I move the movement of that check assembly. Now, to disassemble that check, you can see that that cam arm's right in the middle. I can't take those screws off and replace that rubber disc. This being the 3-inch design, obviously on an 8-inch, we'd have a lot more problem trying to change this check assembly. So, what it's designed for, if you look on the back, whether it's bi-link or tri-link, there are two little slots in the plastic here with a corresponding hole in the middle of the cam arm, bi-link and tri-link. And the function of that linkage that is taken here, put it in place, and what it does is it removes the spring tension off the disc holder. Just enough so that I can take it apart. Now, with that linkage like this, now I can come in on the back side, remove my keeper ring. There it is. Remove the keeper ring. Pin comes out next. Allows the check assembly to fold down. Now when the check assembly folds down, I can go ahead and remove my bolts, replace my rubber disc. So there's this small little pin and this very small little keeper ring that you can see right here that holds that check mechanism together. And I have to release that. I've contained the spring with this pin. In other words, that torsion spring in the middle here is being held by that pin being through here. After I've removed that clip, it'll fold down just like that. Replacing my rubber disc, putting it back together is going to be just the reverse. Bringing it back up here. Go ahead and put my pin together with the linkage. Catching the linkage. Okay, do it so the camera can see it right there. Putting the two arms together. Now go ahead and put the keeper ring back on. Just like that. Once the keeper ring's in place, snap it into the slot. Now I can go ahead and remove my rod, which puts the spring tension back onto the check assembly. Like many things in life, going to a larger size causes a few problems. Hydraulically, mechanically, they work similar, but obviously we get to the larger size, this being a 6 inches to one we just did. Out of the 3-inch, you can see there's some obvious difference in sizes. And this one I was able to pull the check down to demonstrate it, and we were able to put the rod on the back side very easily to show how to rebuild it. Well, when you get to the large size, it's not quite that easy. Obviously we have larger spring, obviously we have larger parts, but more importantly, when you get that rod back here, there is no way you're going to be able to pull that down. This being a 6-inch, and imagine 10-inch being even larger. So if you'll notice what they did on the 6, 8, and 10-inch, is they drilled a hole in the side of the check body. did not do it on the small ones. They only did it on the 6, 8, and 10 inch, like here. And this is to assist us in getting that pivot point. In other words, the small one, I can just push it in and push the pin through and it worked. But this one, because of the larger load, spring load, I can't pull that over. So what we've got is this little hole here that is threaded. And it's designed to hold a bolt. And the bolt looks like this. It is a 1/2 inch bolt, 13 threads per inch, 5 inches long, threaded the entire length. This is a repair tool for the Colt and Maxim series in the sizes 6 through 10. You will need this bolt to fix the first and second checks of the 6, 8, and 10 inch design. And the bolt is designed to go through this hole. And I've got one already pre-loaded here like this. And the intent of that bolt is to go against that cam arm. So now what I can do is tighten that bolt to the point that now my pin will go through. Then I loosen that bolt where the load is now on the pin. Now, by having the load on the pin, you'll notice it's loosened the disc holder. In other words, before the pin is loosened, this disc is hard against that seat. But once I got the pin in place, just like a small one, it loosens it just enough so that now I can go on the back side, remove my small little keeper pin right here, just like we did on the small ones, which I showed you just shortly ago, and the same thing. So now I remove that, now the disc holder will flop down, I can remove my 6 screws and go ahead and change my check disc. Once I've got my disc, I put it back together, realign my linkage just like we did on the small one, and go ahead and I want to tighten the bolt to get the load on the bolt off of the rod, which allows me to pull the pin out. Now I loosen the bolt and can remove it. Now you can see it's completely loose. So now it's tightened back up. So this bolt is very important when you're working on the large 6 through 10 inch sizes, because that bolt goes into this hole. As you can see, you have to thread it in a good 1.5 inches before it starts to touch that cam arm. And once you get to that point, it loads it so that you can slide the pin in. Then you can remove the pin on the back side, opening up the disc holder for a change of the rubber disc. So the smaller ones up to the 4 inch have a little bit different characteristics where we're just able to slide that pin inside. But when we get to the larger sizes, this bolt is critical for a repair. And that's what our larger sizes of the check assemblies are going to look like. So whether it's a bi-link or tri-link, same neat deal. We're going to slide that back pin in there, remove the cam arm, slide that down, and replace the rubber disc. So the disc is replaceable. Reassembly is going to be just the reverse. We're going to go ahead and install that. Remember, our retainer sits like this. So the good news is you cannot put the check assemblies in backwards. Notice there's 2 notches on the body here and none on this side. Well, you put it in here, you'll notice that all of a sudden those notches don't line up because that check assembly doesn't have the notches that one does. Because if you put it in this way, you would never get the cover back on top. So it's not able to reverse the checks. And the first check in next, the retainer in place, like this. Now, as I mentioned, this sleeve just slides across there for the average repair, so it's sitting over here while we're working on the check assemblies. Why we don't want any paint or any rust up here is because as we go to slide this back over here, we don't want to slice the 2 O-rings that sit right in this area right through here. If for some reason you do slice those O-rings, if for some reason you slide it back and turn it on and it's leaking out this body, the only way to replace this O-ring is to drop the entire body out of the shutoff valves, out of the assembly. And you're going to have to drop this down, take it out to get this out of there to change those 2 O-rings. For the normal repair, you do not have to drop the body, but if you do slice those O-rings for any reason, you are going to have to drop the body to change the 2 O-rings inside that inside that sleeve. Reassembling the test cock number 3, O-ring seal, so just hand tight, make sure it's in place. Now, the relief valve First thing you saw, I took it off of the body and leave this nut attached to the relief valve cover. It's not a good idea to remove that if you don't have to, and I'll show you why in just a second. But there are 4 bolts on the back side on the relief valve. Go ahead and remove 4 cover bolts. And the first thing you're going to see is that on that relief valve cover when I take it off, remember on the SS design we had that street L that was sticking out the back, and I had to make sure we lined it up properly so we didn't screw that street L into the rolling diaphragm? Well, we've got that similar rolling diaphragm that you see there, but instead of that street L on the back side, what they actually have is a bolt that has a hole drilled right there, and there's one on the opposite side right there. So this is my high pressure sensing line. High pressure comes through here. They've drilled through the center of that bolt and put 2 counter drills, one here and one on the opposite side, so that the high pressure sensing line comes out in 2 directions. What they found with the earlier SS design is that when that street L was just in the center, when people would turn the relief valve on fast, it would tend to hit this, and it would cock the relief valve to one side or the other. So by putting this where it's on 2 sides coming out of that bolt in a smaller orifice, it allowed the relief valve to close in a more smoother fashion, again causing less problems in the workings of the relief valve. So this is why I don't want you taking this apart if you don't have to. Disconnect it from the body and just put the cover on the side for the repair. Now remember in the last time I said be careful when you gingerly pull out the rolling diaphragm out of the body. This time you don't have to be as gingerly because it is not glued. It's a separate rolling diaphragm. Now remember with the earlier design when it was folded in place and then slid into the body, and we had to fold it in place. This time we get to fold it outside the body. Much easier job. But to remove the stem assembly, because the other one we just shoved it through the body, this one we have to remove a keeper ring. And again, keeper ring on this side comes off here. Keeper ring comes off. Relief valve stem assembly comes out in piece with my relief valve spring. So this is what it looks like inside the body, like that. Again, my relief valve seat is going to be, you see here, the relief valve stem is going to be sitting through here, closing across here. Relief valve seat sits right over here where it's going to close, and that's my relief valve body. Reassembly, when you buy the new relief valve rolling diaphragm, you get that piece, but when you buy the relief valve disc, unfortunately, you have this whole stainless steel piece. Relatively more expensive to buy that whole piece, but that's the stainless, I mean the relief valve disc is molded into the body right there, and again does not come out of that holder. Relief valve seat right in here, you want to inspect it, make sure it works properly. This little piece in here is a very important piece. It's called a spider. And the function of the spider is to hold the spring in a perfectly square to the relief valve stem. We talked earlier about springs, and the worst thing you can do to a spring is hip it. And this spider makes sure that it stays straight, and it does come out, as you can see, like this. So if that spider becomes bent or damaged, it can be easily replaced. But for the normal repair, it does not have to come out of the body. But I wanted to show you how it came out. Like that. Okay. Reassembling, relief valve spring sits here. Now I want to catch those slots on the spider. Now it's important when I shove this through that I make sure the stem comes through the center, but look how the spring is off-centered right now. So I did not center the spring. Now I'm hipping that spring, which is going to change my relief valve opening point. So it's critical that I make sure I get that spring on the 3 little clips in the spider, then insert the stem through the center, which allows me to put my keeper, my E-clip back on over this way. Now, I can go ahead and fold my rolling diaphragm outside of the body, which is much easier to do. Again, O-ring on the back side. Go ahead and attach it with my 4 bolts. Again, if you mark where it came off, that sensing line will go right back on the same place. That way to line up with your sensing line. So always mark the covers before you take them apart on the relief valves, because you don't want to have to twist this. It could cause a leak. Reassembly is going to be just O-ring sealing inside the body. Attach my relief valve here. Again, once I have it tightened up, it just needs to go a 1/4 turn beyond that hand tight. Reattach my sensing line, and that is my C4000 Colt 4000 series Ames assembly.